Hello everyone, I'm going to talk about acids and bases in this chapter. Mostly we call acid and base together. When we say acid and base, we are going to talk about two main group of compounds. In this chapter, first I'm going to review properties of each group, then we are going to apply the information we learned to solve our problems. First, acidic properties. In this screen, you will see one photo when we are going to taste acids. In general, acids have a sour taste. I'm sure you can remember that. Any chemicals with the sour taste you already have experienced. So we may call them acids. The second property of acids, when we say acids dissolve many metals, not all metals. Please look at the examples. I said we cannot dissolve copper, silver, and gold in acids. In other words, if you have silver ring and acid spills on your silver ring, you don't need to be worried about your silver ring. You just need to be worried about your skin. Right now, I'm going to talk about the reaction of metals and acids. If you remember, we reviewed that one in earlier chapters. If we have one element like metals and one compound like acids, this reaction of element and compound, we call them single displacement reaction. So please review single displacement reaction on your mind. Reaction of metal and acid is going to be one example of single displacement reaction. The next property of acid is the basic identification of acids in the chemistry labs. Whenever you have a bottle of liquids, bottle of solution, or any bottle with no label, when we are going to identify type of chemicals, we need to do some experiment. This method that we are going to check to identify, to test our compounds, we call that identification method. To do this, we need to have one indicator. Indicator we use here in the lab is like this basic indicator you see on the right side. This indicator is going to be called litmus paper. If we have blue color litmus paper and we add a couple drops of acid to that, we are going to have these changes. Acids turn blue litmus paper to red. So always the red color represents acidic chemicals when we use litmus paper. Another part of the properties of acid that I'm going to share with you, this photo, reaction of metals with acids. Whenever you react metals with acid, you are going to make hydrogen gas. So these tiny and small bubbles, they are hydrogen gas. So if we are going to produce hydrogen gas in the chemistry, we react acids and metals. If I'm going to talk about basic properties or properties and characteristics of bases, I'm going to talk about their taste again. Taste of the basic compound is bitter. So as you see here, we may call some major or main resource of bases alkaloids. So they are plant products. We may call them alkaline. So if you remember that group 1, group 2 elements, we use the same or similar terms. Alkaline earth metals, alkali. It means they can make bases. For bases, in the later slides, you will see that we have mainly metals, they make bases. Another properties for them, they are going to have a slippery fill. What does that mean? It means they are going to have a soap-like, and we are going to have this experience in our daily life. If you add soap or any detergent, any body wash, hand wash, you may have like this filling. This filling, it means you use bases. So it means bases can be used in our daily life. The next properties of the bases, when we are going to have litmus paper. At this time, if we use red litmus paper, they are going to make blue bases, they are going to make blue color. So it's easy to memorize. Acids make red, bases make blue. Bases B make blue. In chemistry, we have some theories to define acids and bases. The first and basic theory is Arrhenius theory. Based on Arrhenius theory that we earlier used in our class, we may say acids start with hydrogen. They have hydrogen at the beginning. So if we have a formula of compound, if we have like this one, H at the beginning, we call them acids. So let me write like this one. If we have H at the beginning and if we have non-metal at the end, so H non-metal. Look here, HCl. This is this is one example of acids. So HCl is acid because it starts with hydrogen. Another example is HNO3. When we start with hydrogen and then we have nonmetals, a group of nonmetals. So we call it acid. All acids, they dissolve in water. So we use like this one, aqueous. So acids, they have two types of notation to represent them. H at the beginning and aqueous as a state of matter. When we are going to talk about Arrhenius theory, we are going to talk about this definition. Acids react, acids contain a hydrogen atom and dissolve in water to form hydrogen ion and H or H plus. So I may ask you to consider that one. If we have acid, we add to water, it means we can dissolve it in water. So they are going to produce H plus. So if we have any acids, like this example, if I'm going to write the product based on the Arrhenius theory, acids, they are going to produce H plus and the rest of the compound is going to be negative. H plus dissolve in water, NO3 dissolve in water. Nitric acid, HNO3 dissolve in water. So if we are going to write that, we may write this HCl aqueous. So we may write HCl aqueous as well. So no worries about that. Definition, it means they can dissolve hydrogen, in the water. Let me talk about bases. Based on Arrhenius theory, bases, they are going to have OH and they are going to produce OH. If I'm going to talk about bases, I may say metals and OH make bases. It means if we have a chemical formula composed of metals and N2OH. Example for that is NaOH. So acids start with hydrogen and we have nonmetals. Bases, we have metals and they end to OH. HOH for acid, for base. When we say Arrhenius theory definition for bases, it means they can dissolve in water and they produce OH minus. OH minus. So they dissolve in water, so that is why we write aqueous force. One thing I may ask you to pay attention for metal and non-metal part. Always metals make like this compound OH, we call that metal hydroxide. Sodium hydroxide. Sodium hydroxide. So metal plus OH. And for non-metal, we say H and non-metal for acids. So H and non-metal. So the name of the compound is going to be hydro, it's not hydro, sorry. It's hydro plus non-metal plus ic acid in this example. Hydro, non-metal, ic acid. So we call that hydrochloric acid. One thing we should remember that the Arrhenius story, it goes back to early 20th century. So it's going to back about over 100 years ago, 120 years ago. So it's going to be revised and it should be considered some revision for this theory because it's not going to predict all of the acids and bases. We have some compounds like sodium, hydrogen, carbonate. This is a base. This is a base. But we cannot say it ends to OH. We don't see it has OH. So Arrhenius theory should be revised. Another one based on the definition. It says acids, they produce H+. H+, if I'm going to talk about that, if you remember, hydrogen has this information. Hydrogen, if you look at the periodic table, 1 proton, 1 electron, and the number of neutrons is going to be 0. 0 neutrons. If I say H+, it means this hydrogen loses 1 electron. So it's going to have only 1 proton, 0 electron because it lost its electron, and the neutron, it would be same, 0 neutron. So this ion, it doesn't have neutron and electron, so it has only 1 proton. Sometimes we call that proton. So Arrhenius theory said acids dissolve in water and they produce H+. They produce proton. And that is why we say we need to work on some definitions because it should be more accurate here. Before moving forward, I'm going to talk about some definition we may consider for acids. I may ask you to pay attention. If we have like this acid, HCl, HNO3, assume that they are acids and let me write aqueous for them. For this one, these two, I call them, they are monoprotic acid. Protic means we are talking about proton. Mono, it means they have only 1 hydrogen, only 1. If we have 2 hydrogens for our acid, like H2SO4, H2CO3, we may call them, this group of acids, they are diprotic acid. Diprotic acid. So you don't need to use the identify the type of acid like this, But in general, if we have question, what type of acids do we have? Monoprotic, diprotic, it means we are going to talk about the number of hydrogen, 2, 3. If I'm going to ask you, I'm sure you are going to answer my question correctly. What type of acids do we have? I'm sure you are going to say that we are going to work with triprotic acids. Triprotic acid. Again, we are talking about H in chemistry based on the definition that we have. We call it protons. Next definition or next theory, we call that Bronsted-Lowry theory. I may ask you, please memorize these definitions. Bronsted-Lowry acid has this basic definition. Chemicals, they are proton donor, and bases, they are chemicals proton acceptor. So two definitions should be memorized in this chapter. Bronsted-Lowry theory. It says we have these two definitions. For acids, they are proton donor, and bases, they are proton acceptor. Look at this reaction. Assume that we have a reaction of HCl and H2O, and we are going to identify which one is going to be acid, which one is going to be base. Always, when we are going to define Bronsted-Lowry theory, so we are going to define these two definitions. Define these two compounds. Define something that it helps us to solve our problems. Proton donor, proton acceptor. I repeated that one a couple times to make sure you understand. Acids, they are proton donor. In other words, I'm sure you can confirm that if we have acids, they should have hydrogen in the formula to donate that. So acids, they need to have hydrogen in their formula to donate. If they don't have hydrogen, they cannot donate. So we never call them acids. So acids, they have hydrogen in the formula and they donate their hydrogen. Look at this formula. I'm going to work with these two compounds. I'm going to know which one is going to be acid. Both have hydrogen. I cannot define based on the definition. Both HCl and H2O, they have hydrogen. I cannot say which one is acid, which one is base, based on this definition. I'm going to compare these two based on definitions we have. How to do this? You are going to compare similar formula. You just need to compare the similar formula in the reaction. What does that mean? It means if I have HCl, I'm going to compare with one of these two, H3O plus Cl minus. Which one is similar to HCl? So you may say Cl minus, Cl1 negative, HCl, Cl1 negative. What is the difference between these two? HCl has hydrogen, but here it doesn't have hydrogen. So when we have hydrogen, H plus, here there is no H plus. We have Cl minus. So it looks HCl donates its hydrogen. HCl is proton donor. It donates its hydrogen. Donating hydrogen, we call that acid. For base, let me look at this one. I'm going to look at the next one. H2O, I'm going to compare with the formula similar to this one, H3O plus. H2O, H3O plus. They are similar to each other. What is the difference between these two? Here we have 2 hydrogen. Here we have 3 hydrogen. Also, we have 1 positive. Look, there is no positive. We have 1 positive. So difference between these two, it means 1 more hydrogen with positive charge. So it looks this compound, H2O, accept 1 hydrogen positive to make H3O plus. Accepting hydrogen, we call that base, hydrogen acceptor. So always we have a reaction between acid and bases. Acids are hydrogen donor and bases are hydrogen acceptor. In this scenario, you are going to see this explanation. Please remember the definition we work on. Proton donor acids, proton acceptor bases. So HCl is going to be proton donor because we compare with Cl minus, and H2O is going to be base because it's going to accept hydrogen. I'm going to ask you, please pay attention. Please pay attention. When we say acids and bases, we are going to talk about a reaction between reactants. Always you may find acids and bases on the left side, only on the left side. Don't call this one is acid, don't call this one is base, or vice versa. Only acid and bases are placed on the left side. Let me have a quick review. Bronsted-Lowry acid must contain a hydrogen atom because it's going to donate hydrogen. If it doesn't have hydrogen, it cannot donate. We don't call it acid. So if we have acids, we have some specific name for them. Hydrochloric acid, hydrobromic acid, nitric acid. Please remember the nomenclature rule from chapter 5. If we have binary acids and if we have polyatomic acids, you need to know the name of NO3 nitrate and change that one to ic acid. So we call it nitric acid. So let me work on bases. Bases, most likely they are metals and OH. OH is one of the polyatomic ions, you call that hydroxide. So when we say sodium hydroxide, it means we talk about a base. In general, in advanced chemistry courses, we are going to work by details why we lose hydrogen, why we gain hydrogen for some substances. In this chapter, I'm going to ask you only memorize acids are hydrogen donor, or in other words, H plus proton donor, and bases are going to be hydrogen plus or proton acceptor. One thing I'm going to ask you, please look here. If you are going to combine, if you are going to add acid to base in this reaction, if we are going to compare acid with one substance similar to that one, we call this one acid. So you look at these two, you may say it has hydrogen, there is no hydrogen, so we call that acid because it is going to lose hydrogen. This one on the right side, we call that conjugate base. If we have acid, we are going to call that conjugate base. You just need to change the name of acid to base and call that conjugate base. For base, if we have this one and we compare with this, it's going to gain hydrogen, so we call that conjugate. conjugate, we switch this term, we call that acid. So two definition. Acids, they are going to make conjugate base, and base, they are going to consider conjugate acid. Conjugate base and conjugate acid, always they are going to place on the right side of the periodic table. Acids and bases, always they are going to be on the left side of the periodic table. In this reaction, if we are going to review, HBr is going to make Br1 negative. We call that acid, so Br1 negative is conjugate base. H2O is going to consider as base because it's going to gain H+. So base, we call that the H3O plus conjugate acid. In reactions that we reviewed here, H2O in this example is base. In some example, H2O can act like an acid. So in these examples, I'm going to review H2O is base. Look, you said base. In this example, you said H2O is base. But I'm going to show you how to call H2O is an acid. Please look at this example. NH3 plus H2O, it's going to make NH4 plus and OH minus. I'm going to compare NH3 with NH4 plus. Here 3 hydrogens, here 4 hydrogen. It gains hydrogen positive. I write it base. So this one I'm going to call that conjugate acid. This one H2O I'm going to compare with OH minus. H2O 2 hydrogens, H1 hydrogens. It's going to lose hydrogen, donating hydrogen acid. So I'm going to switch the term and I call that conjugate base. In this reaction, H2O is base. In the previous examples, I showed you we had base. H2O is base, H2O is acid. So H2O sometimes act like an acid, sometimes act like a base. Some substances like H2O, when they act like an acid and act like a base, we call them amphoteric compounds. Amphoteric compound. So as you see here, if we have H2O base, it's going to gain hydrogen, so it's going to make H3O plus. We call it conjugate acid. This term used for H3O plus. This term, hydronium. Hydronium is the formula of H3O plus. If we have H2O and it's going to act like an acid, it should lose one hydrogen. Losing hydrogen, we make OH1 negative. We may call that hydroxide. Hydroxide, OH1 negative. I may ask you to work on this example. This is the last example in this chapter. We are going to know what is the Bronsted-Lowry acid, which one is the Bronsted-Lowry base, or which one is the Bronsted-Lowry conjugate acid, Bronsted-Lowry conjugate base. So you may pause the video, solve the problem, and back here. Right now, I'm going to say that we are going to compare this one with similar structure. It has carbon, I'm going to compare with the carbon. One hydrogen, no hydrogen. It means losing hydrogen, donating hydrogen. I call that acid, Bronsted-Lowry acid. And I call the compared formula conjugate acid. I'm going to change that one to base. So conjugate base. So I could find conjugate base and acid here. In this example, H2O is going to compare with H3O plus. Two hydrogens is going to be 3 here. So it's going to gain, it's going to accept base. H2O is base. And I'm going to write this one. We call it conjugate acid. Hope you learned the meaning of acid and base in the chemistry.